Hey everyone, welcome back to the channel. My name is John and this is your Modern Tech Breakdown. Today I'm going to break down the CrowdStrike outage from last week. It's a bit technical, but my aim is to describe it in easily understandable terms. Let's jump into it. Alright, so CrowdStrike released their preliminary post-incident review, which is basically their version of an early post-mortem on what happened last week that brought major airlines to a halt and widely affected almost every business on planet Earth. So I've read through the release. And before we get into it, I have to say that the way this is written is interesting. The author uses a ton of capitalized terms that seem to be CrowdStrike internal names for various components of their system. If I were conspiratorial in nature, I might think CrowdStrike was intentionally using an arcane vernacular in order to prevent the majority of readers from understanding what happened. I suppose it's possible this was written by a technical author that is a stickler for technically precise terminology, but the net result is the same. If you're not a fairly technical reader, this report is probably going to be a little difficult to understand. With that said, let's get into it. So right out of the gate, the report outlines two key pieces of its Falcon sensor software, sensor content and, quote, rapid response content. Based on my reading of the report, I believe that sensor content is the code or software that gets distributed to CrowdStrike customers and must be installed on every covered machine. And at this point, it's important to note, my understanding is that this, quote, sensor content runs inside the Windows kernel. This is important to note for reasons I'll get into later. The, quote, rapid response content is more or less the data that is used by the sensor software as a list of things to check for. If you've ever used antivirus software and you've seen a screen that says updating virus definitions, for CrowdStrike, the rapid response content is the virus definitions. So to summarize thus far, we have two key components of the Falcon system. There's the software that gets installed like any other on the machine, and the data that the software uses as a list of things to look for. So there's two main things, the code and the data. For my read of this report, it doesn't seem like the code gets updated all that frequently. The data or the rapid response content is what gets regularly updated. The report goes into a little detail about all the testing that CrowdStrike does on the code part of the system. This makes sense. The so-called sensor content is typical software and would be treated to the same testing process as any other piece of enterprise software. But I think it's interesting CrowdStrike included this commentary in this report, as it seems that CrowdStrike is trying to give the impression that they have a rigorous testing process. But the code wasn't really the full cause of the issue. Now that we understand these two pieces of the system, we can discuss what caused the issue last week. The culprit was an update to the rapid response content. Remember, this is akin to the virus definitions. This data, no doubt, includes a list of places to look on the computer for viruses or malware. This would likely include places on the hard drive and, more importantly, places to look in memory on the computer while the computer is running. Now, it's interesting. CrowdStrike explicitly states that the rapid response content is, quote, not code. Well, actually, it kind of is. It is code in the sense that the data significantly impacts how the code runs and what the code does. This is a common discussion with developers, data as code. If the data changes what the program does, couldn't you view the data just like the code? Anyway, enough of this philosophy talk. What happened on Friday was CrowdStrike sent a data update to all systems. The so-called rapid response data caused the sensor software to read out-of-bounds memory that triggered an exception. An exception in software means that a situation that is anomalous or exceptional. An example would be asking the CPU to divide by 0. The result of dividing by 0 is undefined, and when this happens, the CPU raises an exception. Typically, when this happens, the operating system has specific code called exception handlers, oddly enough, that deal with this situation and allow the system to keep operating. However, in this case, remember that the software that caused the exception is in the kernel itself, and bad things happen when exceptions occur inside the kernel. Things like blue screens of death. So that's it. That's all it took to bring the world to a halt. Now, what is CrowdStrike going to do to prevent this from happening in the future? They listed several things, but I'll call out two of them. The first is they're going to enhance their validation checks on the rapid response content. Honestly, it's pathetic that they didn't have this check already in place. Verifying that out-of-bounds memory isn't accessed seems absolutely obvious to me. So definitely good that they're adding it now, but it's quite embarrassing they didn't have that before. Second, they're going to stagger their deployment of rapid response content to the user base in order to detect issues before they impact the entire world. Again, this is so beyond obvious, it's embarrassing that they don't already do this. To wrap things up, I'll summarize what happened. CrowdStrike distributed bad virus definitions to all its customers, which caused their software to raise an exception. This exception caused the dreaded blue screen of death because it happened inside the Windows kernel. So I hope this was helpful for everybody. I found it rather interesting. Like I mentioned, it was a bit technical today, but this was such a huge story, I felt like the audience would appreciate a breakdown on it. And with that, I'll close out this video. Thanks for watching. Please like, comment, subscribe, and I'll catch you next time.